These values of complex numbers we can see are true for all values of n, where n is a positive integer. And you know that an integer is a positive whole number. So I to the power 2 plus 4n always gives us negative 1. I to the power 3 plus 4n always gives us negative I. I to the power 4 plus 4n is always going to give a 1. I to the power 5 plus 4n is always going to give a positive I. Now, let's look at some questions. Express the following in the form a plus ib. Starting with the first one, 5i, then we've got 2 plus 6i plus negative 2 plus 5i. So what we can do is we can multiply the 5i with everything that is inside there. That is going to give us 5i times 2, that would be a 10i. And then we've got a plus there, 5i times 6i, that is going to be 30i squared. And then we can also expand the positive times a negative 2 there, that is going to give us a negative 2. Positive times positive 5i, that is going to give us a positive 5i. Now at this point, where there is I squared, we are going to substitute a negative 1. So that is going to give us 10i plus 30. We put a negative 1 there, and then minus 2 plus 5i. So 30 times negative 1 is a negative 30. And we bring together with a negative 2. And then we have got a positive 5i, and then a positive 10i. So this is going to give us negative 32 plus 15i. So we have expressed it in the wanted form, a plus ib, where we can see this is going to be a, and then this is going to be b. So where they say ib, it's the same as bi. So we can also write this as negative 32 plus I 15. But mostly when you are dealing with numbers, you'd rather let a letter be this side. Alright, let's consider the second one. I to the power 101. How can we write it in the form a plus ib? So what we want to do for this one is we want to see if we can write it in which form does I to the power 101 exist. Is it in this form, this form, this form, or this form? Only one of these forms is going to be true for I to the power 101, and then we are going to be able to get the value, which is this side. Then we would have already written it. So we can start with where we know 101. At least we know it is an odd number. So let's get those which are odd numbers. This one and this one. That would be much simple for us to go with, other than testing everything. So get I to the power 3 plus 4i. So let's say I to the power 105 is equal to I to the power 3 plus 4n, I mean, not 4i. Alright, now since the bases are the same, we're going to equate the powers. So that is going to be 101 is equal to 3 plus 4n. If we take 3 the other side, that will be 101 minus 3, and that is going to give us 98. So that will be 98 is equal to 4n. To remain with n, we'll divide 98 by 4, and that is going to give us n being equal to 24.5. And we know 24.5 is not an integer, so this won't work. Let's try I to the power 5 plus 4n. So again, the bases are the same. We equate the powers. That is going to give us 101 is equal to 5 plus 4n. Taking 5 the other side, that would be 101 minus 5. That is going to give us 96. So 96 is going to be equal to 4n. Now divide by 4 to remain with n. So n is giving us 24. And we know 24 is an integer. So that means I to the power 101 is equal to I to the power 5 plus 4. Now where there is n, the value for n we are putting there is 24. Now, since I to the power 101 can be written in this form, and we know that whenever we write something in this form, the value should be giving us an I. So if it is 5 plus 4n, always it should give you an I. I to the power 4 plus 4n, it should always give you a 1. So we need to know at least this, or if not to master them, we know how to get them, and the video is there on how to get those. So this is giving us a value to be an I. So what you say is, since I to the power 101 is equal to I to the power 5 plus 4n, where our n is equal to 24, then I to the power 101 is supposed to give us what? An I, because we know it can be written in this form. And so that will be the form a plus ib. It's just that a, if we write it in the form a plus ib, we don't have a because a is 0. So it is just along the imaginary axis. There is no real value. That is why it is written in that form. Alright, let's consider the last one that we have on here. Part C, that is -3, -1 plus 3i, and this was supposed to be squared, sorry for that. That is squared, and then you've got plus the absolute value of 4 minus 3i. So we want to express it in the form a plus ib. So how do we go about it? The first thing we want to do is we want to expand this one, which is here. Now the simplest way of expanding something that is raised to the power 2 is get the first number, square it. -1 squared will give us a +1. And then get this, multiply by this, multiply by that. So that will be 2 times -1 times 3i. That is going to give us -6i. And then after that, get this number here, square it. That will be 3i squared. 3 squared is 9. And then we've got i squared. And then we've got plus the absolute value of 4 minus 3i. Well, I can just go direct and work with the absolute value of 4 minus 3i. When we're talking about the absolute value or the modulus of 4 minus 3i, all you get is the first number you have there, square it, plus the second number that you have, square it, and then square root. So that will be it. Another way that we can expand this is we write -1 plus 3i, again -1 plus 3i. So that will be -1 times -1 will be +1, -1 times 3, that will be -3i, and then 3i times -1, that will be -3i. 3i times 3i, that will be 9i squared. -3i minus 3i, that should give us -6i, and then you've got 9i squared, which is the same value as which we found at that point. Well, we can go on. Where there is I squared, we can substitute with a -1, and so this is going to give us 1 minus 6i plus 9, -1 there, and that will be plus the square root of 4 squared is 16, 3 squared is a 9, and so this is going to give us a -1, and then a -9. We can now take it to where there is a 1 to put like terms together. So that will be 1 minus 9 and then minus 6i plus the root of 16 plus 9. 16 plus 9 is 25. The root of 25 is a 5. So this will be 1 minus 9, that is a -8. -8 we can add a 5. So that will be -8 plus 5 and then minus 6i. -8 plus 5 should give us a -3, then minus 6i. So this is the wanted form a plus ib. Let's look at this one. Given that z is equal to -1 plus 2i and 1 over w is equal to 1 minus 2z plus z, find w in the form a plus ib. Now, we've been told that 1 over w is equal to 1 minus 2z plus z. So we can go on. We want to find the value of w. We can go and substitute where there is z. So this will give us 2. Where there is z, we've been told z is negative 1 plus 2i. Again plus z, which is negative 1 plus 2i. So we can go on simplifying this, and that will give us 1 over w being equal to 1 minus, okay, negative 2 times negative 1, that will give us positive 2. Negative 2 times positive 2i, that will give us negative 4i. And then we've got negative 1 plus 2i. So this will give us 1 over w being equal to, well, at this point we can add the like terms. This is a positive 1, and then we have got a positive 2, we have got a negative 1. So 1 plus 2 minus 1, all we can see here is this negative 1 and this positive 1 is going to cancel. So we're going to remain with a positive 2 here. And then we have got negative 4 plus 2i. That is going to give us negative 2i. Now, since we have got 1 over w, if we take w on top, that means, of course, this is the same as 2 minus 2i over 1. So if w goes on top, 1 comes down, then 2 minus 2i will come down, and then 1 is going to go on top. So that will become w is equal to 1 over 2 minus 2i. Now at this point we want it to be written in the form a plus I, but we can conjugate. So we're going to multiply the denominator and the numerator by what we can see in the denominator, but we get its conjugate. The conjugate of a complex number is just changing the sign of the imaginary part. So we're going to multiply by 2 plus 2i, even down by 2 plus 2i. And so that is going to give us w being equal to 1 times 2 plus 2i will be 2 plus 2i. And that will be divided. When we are multiplying a complex number by its conjugate, just get the first part that you've been given, square it, plus get the number in front of the I, also square it. So that will be negative 2 squared. Okay. Please, it should always be in the brackets, because if it is not, then that negative won't be gone. So this will give us 2 plus 2i divided by 2 squared is a 4, and then negative 2 squared is also a 4. So that is going to give us 4 plus 4, which is 8. And we can write this as 2 over 8 plus 2 over 8i, which can also be simplified as 1 over 4 plus 1 over 4i. So that is the wanted form. Let's consider the second one, b. Want to express 3 minus 2i over I to the power 204 in the form a plus ib. So the first thing that we want to do is first be able to simplify this one. I to the power 204, is it equal to I, negative I, 1 or negative 1? Now the way to do that is to just look at these values which are here. Well, for me, I can just tell that it should be in this form. And how do I tell? We have got I to the power 204. We know that 204 minus 4 is supposed to give us 200. And 200 divided by 4 is a 50. So what I'm saying is I to the power 204 is equal to I to the power 4 plus 4n. So if something is like this, then we can equate the powers because the bases are the same. That will give us 204 is equal to 4 plus 4n. So this is going to give us, we take the 4 this side, it becomes negative. So that will be 200 is equal to 4n. To remain with n, we divide by 4 on both sides. And so n is giving us 50. And 50 we know is an integer. So this is equal to 3 minus 2i over 1, which is just 3 minus 2i. So that means it has been written in the form a plus ib. Now what if it was 3 minus 2i divided by I to the power 200? How do you go about this one? Well, again, we need to see how we can write I to the power 200. Is it equal to I negative I 1 or negative 1? So let's try this. If we say I to the power 200 is equal to I to the power 2 plus 4n, we equate the powers. That will give us 200 being equal to 2 plus 4n. If we take 200 the other side, that is going to give us 198 being equal to 4n. So to remain with n, we are supposed to divide 198 by a 4. And that will give us 49.5. And that won't work. So we see that, again, even 200 will be written in this same form, which is I to the power 4 plus 4n. That means even 200 will be equal to a 1. So say we had something like if it was the 3 minus 2i divided by I to the power 202. Let's put it in that form. Okay, so if it was in this form, I to the power 202, let's equate it to I to the power 2 plus 4n. So since we've equated it to that, we are supposed to equate the powers because the bases are the same. If we take 2 this side, that will become a 200, and that will be equal to 4n, and n is going to give us 50. So I to the power 202 can be written in this form. Now what is the value if we write something in that form? So we see that the value is negative 1, and so that is going to be equal to 3 minus 2i over negative 1, which we can also split as 3 over negative 1 minus 2 over negative 1, and then we've got an I, and this is going to give us negative 3 plus 2i. So whatsoever that you've been given, you need first to simplify what is in the denominator, and then you go. If it gave you an I down, that would be 3 minus 2i over I. And so what you would have done is to conjugate. So to conjugate something like that, you multiply the down and the up by an I. So that would be 3 times I, that will give 3i. Negative 2i by I, that will give negative 2i squared, and divided by I times I, that will be I squared. Where there is I squared, we are going to put a negative 2. I mean a negative 1, because we know the value of I squared is negative 1. So that will be negative 2 times negative 1, that will be positive 2, which we can also start by saying 2 and then plus 3i, and that will be divided by I squared is equal to negative 1. And so this would be negative 2 minus 3i if we split. So this one goes into that, and then the same one goes also into that. So that is how we get the values on this one.